So, today we're going to dig into a fascinating study that asks a really bold question. Can you take the world's oil heartland and turn it into a green energy powerhouse? Let's get into it.
I mean, it sounds kind of crazy, right? The very region that's powered our world with fossil fuels for a century, could it really flip the switch to a completely renewable energy system? That's a huge question, but it's one that a team of researchers decided to tackle head-on.
And that's exactly what we're diving into here. This wasn't just speculation. A super detailed scientific study from Lapinranta University of Technology actually modeled the whole thing. And you know what they found? It's not just possible, it actually makes a ton of economic sense.
Okay, so to really get why this is such a big deal, you first have to understand this paradox that the Middle East and North Africa region is facing. It's a place with unbelievable energy wealth, but at the same time, it's dealing with some really intense problems at home.
Think about it. Electricity demand is just exploding because of population growth. And on top of that, it's one of the most climate-vulnerable and water-scarce places on the entire planet. So, just relying on the old fossil fuels to power everything, from air conditioners to making fresh water, is becoming this really vicious, unsustainable cycle. But here's the wild part. The other side of that paradox. For all its challenges, the MENA region is sitting on a staggering 45% of the entire world's solar power potential. That's almost half. The very thing that makes life so tough there, that intense sun, is also its single greatest energy asset.
So this brings us to the really radical question the researchers asked. What if, instead of just adding a few solar panels here and there, what if the entire region just went all in? What would it actually take to build a 100% renewable system, and could it even work?
And look, this wasn't just some back-of-the-napkin idea. Their goal is to build a super detailed, hour-by-hour model of a fully renewable system across 19 different countries, looking ahead to the year 2030. They tested not just if it was technically possible, but if it made any financial sense.
So, how on earth do you even begin to do something like this? Well, the solution they came up with isn't just about building more solar farms and wind turbines. It's about connecting all of them together in what they call a supergrid. The easiest way to think about it is like an energy internet. A supergrid uses these incredibly efficient cables, called HVDC lines, to move huge amounts of power across vast distances with very little energy getting lost along the way. So a country that's windy at night can shoot its extra power over to a country that's sunny during the day. It just smooths everything out.
And, this idea has been floating around for a while. You might have heard of concepts like Desertec, which imagined these huge grids sending clean power all the way from the Sahara to Europe. It just shows you the scale of thinking here. We're talking about connecting continents, not just countries. So the study put this to the test. They modeled a few different versions of the supergrid. On the left, you've got a pretty simple setup, just connecting the countries. But on the right, it gets more complex, with countries clustered into these bigger collaborative zones. So the real question becomes, does all this cooperation actually pay off? And that brings us to the heart of it. The researchers ran 3 totally different scenarios to see how much of a difference all this teamwork really makes. And trust me, this is where the numbers get really, really exciting. First up, the baseline. In this scenario, every little region has to generate 100% of its own clean power. There's no sharing, no big grid connecting them. Everybody is their own little energy island. So in this going-it-alone world, the total cost to produce the power comes out to 61 euros per megawatt hour. Now that's actually not bad, but the catch is every single one of those islands has to build a ton of expensive batteries and storage to keep the lights on.
Okay, but now let's look at scenario 2. Here, we connect all those little islands with that big supergrid we were talking about. And suddenly, countries can trade power, sharing their sunshine and their wind across the whole network.
And boom, just by connecting everybody and letting them cooperate, the cost drops 10%, down to 55 euros. Why? Because it's way, way cheaper to share power than it is for every single region to build its own mountain of batteries. But they didn't stop there.
The final scenario. This is the most ambitious one. This is the whole shebang. It takes that connected supergrid and links it up with 2 other huge energy users, water desalination and making industrial gas. And get this, by doing that, the cost just falls through the floor, plummeting another 33%, all the way down to just 37 euros per megawatt hour. I mean, this isn't just a little bit cheaper. This is a total game changer. It makes this clean energy system cheaper than building new fossil fuel plants.
Okay, so you're probably wondering, how in the world did they get the price to drop that much? Well, the secret sauce is a brilliant idea called sector coupling, which is just a fancy way of saying you use every last drop of clean power in a really smart way.
So let's look at how this all works. On the left, you've got all your clean energy coming in. Solar, wind, you name it. A lot of that goes to power the main grid. But here's the key. Whenever there's extra power, instead of wasting it, it gets sent over to power two other things the region desperately needs, making fresh water and creating clean gas for industry. It makes the whole system super flexible.
This chart really shows you the magic. See those huge blue and green bars on the left? That's all your solar and wind power pouring in. Now follow the lines. A big chunk goes right to the grid for homes and businesses. But notice how a big stream gets diverted down to power desalination and industrial gas. Those sectors act like a giant, productive sponge, just soaking up all the extra energy that would otherwise need crazy expensive batteries.
And the benefits are just incredible. The system becomes massively flexible. It slashes the need for expensive battery storage by a whopping 87%. At the same time, it's solving two other huge problems by making clean water and zero-carbon fuel. And get this, it's so efficient it actually lowers the total amount of electricity you need to generate in the first place.
You don't have to take my word for it. The study's own conclusion just puts it right out there. A 100% renewable system isn't some pie-in-the-sky dream. It is, and I'm quoting here, a real policy and low-cost option.
So when you boil it all down, it's pretty simple. The technology is there. The economics make perfect sense. The only piece of the puzzle that's left is political will. Can a region that's been defined by fossil fuel competition find a new path forward in clean energy cooperation? Well, that's the multi-trillion-dollar question.